Good morning. So today we're looking at the second paper, June, of the grade 9 after the study and master on page 191. Okay. So at this point you guys have answered all the questions. So just let me know whatever you don't understand, we'll take it from there. Okay. So the first question says, complete by only writing down the missing parts. The complement of x degrees is. So what is complement? The complement is what? The angles it adds up to? 90 degrees. So what's the complement of x? 90 minus x. What's the complement of 20? What's the complement of 20 degrees? 70 degrees. So we take 90 degrees and we minus the angle given. Okay? Every angle of equilateral triangle is equal. Is equal to what? It's equal to 60 degrees. Remember, in an equilateral triangle, all angles and all sides are equal. Not so. So equilateral triangle, all angles equal to 60 degrees. If one of the base angles of an isosceles triangle is 40 degrees, so an isosceles triangle, one of the base angles, so you got 40 degrees. What's the size of this angle here? 40. What's the size of that angle? Angles and triangles adds up to 180, so that's 100 degrees. Not so? The size of the vertical angle, that is the vertical angle that you're referring to, is going to be 100 degrees. You will agree with that? Vertically opposite angles are equal if two lines intersect one another. Remember that theorem? Vertically opposite angles are equal. Not so? When two lines intersect one another. Okay? Next question. The sum of two interior angles of a triangle is equal to. The sum of two interior angles of a triangle is equal to the exterior angle. Exterior angle. It must be the opposite exterior angle. No? It was the opposite. Opposite exterior. If determine the size of angle x, if x is an angle which is twice the size of its complement. Determine the size of x if x is an angle that is twice the size of its complement. X is twice the size of its complement. You all agree with that statement? That equation thing? Again, determine the size of angle x. You must solve for x. If x is an angle which is twice the size of the complement. Okay? So we multiply x by 2. So we take it over, becomes 3x is equal to 90. X is then equal to 30. Okay, according to the book, I'm wrong, let's check. Determine the size of x. If x is an angle, no, then I'm wrong. X is twice the angle of twice the size of its complement. Is that correct? That should be correct, no? So 2 times the complement will be equal to x. Okay? So you multiply that out, gives you 180 minus 2x equals x. Gives you 3x is equal to 180. X is equal to 60. That is correct. This is incorrect here. No? You all agree with that so far? Okay. Who got F right? Nobody? Only you. Yes? Any of the other sums that you're a bit confused about before we move on? Everything else is fine. Okay. Sorry about that again. Let's look at question 2. A. Calculate x and COD with reason. So we calculate x. How do we calculate x in this case? Angles in a straight line. So it's going to be 2x, yes? Plus 3x plus x equals? Y? Angles on straight line. Not so? So 2x plus 3x plus x is going to give you 6x equals 180. So x is equal to 30 degrees. Okay? But I have answered the question completely. No. The question says you must calculate COD as well. So COD. This angle here they want you to calculate. So for the angle COD, it's equal to 3x. So what is x? 30. So 3 times 30 is 90 degrees. Any confusion here? Any confusion? Let's look at B. B says, from the diagram, write down all pairs of vertically opposite angles. All the pairs of vertically opposite angles. So you get the first case. D is vertically opposite to F. And E is vertically opposite to C, or C is equal to vertically opposite to F. Not so? Any confusion there? Let's look at number 2. All pair of complementary angles. What does complementary mean? 90 degrees. So which two angles adds up to 90 degrees? A and B. So A plus B is 90. Or you could have written A and B. Or complement. You all agree with that? Okay. There's another one. There's another one. Anybody? G and H. Why is G plus H 90? Sum of triangles. You see this is already 90 degrees. So this angle plus that angle must add up to 180. Not so? So that plus this equals 180 minus 90, which is 90. So those two angles are complementary as well. Okay? You can write it like that, or you could have said G and H are complementary as well. Okay? Same thing. Number 3. An adjacent angle to angle C. An angle adjacent to angle C. What does adjacent mean? Next to. So adjacent angles are angles that shares the same vertex and the same arm. So there, the vertex and arm. Vertex and arm. Can you see? So which angles is adjacent to C? Angle D and angle F. Okay, we can just say D and F. You all okay with that? Let's look at number 4. A pair of adjacent supplementary angles. So what does adjacent mean? Next to each other. What does supplementary mean? As up to one. But we know that angles on a straight line is also adjacent supplementary, not so? So which angles are adjacent supplementary? C and F. Okay? Or we could have said angle C plus angle F is 180. This is also acceptable. There's another one. E and F. There's another one. F and DS. And there's another one. C and D. Okay? You all okay with that? Let's look at the third one. Question 3. We are told that in the diagram, you see here, you must be able to read this here and know exactly which angle they refer to. Okay? And you also need to know how to name an angle properly. So BAC, there's BAC. You see this angle here? It's 120 degrees. ACE. ACE is 115 degrees. Calculate angle 1 with reason. Angle 1 with reason. So if you look at where angle 1 lies, it's this angle here, not so. So that angle is the same as which angle? As which angle, people? DCE or ECD. Not so. So how are we going to do that? Co-interiors. She said I must first work out this angle here. You all agree with that? And she said you must use co-interior. So we're going to say 120 degrees plus AC D equals 180. Why? Co-interior angles. With AB being parallel to CD. Okay? So ACD is equal to 180 minus 120, which is 60 degrees. Now what? Yes, now we can calculate DCE. I'm going to calculate this angle here. 115 degrees minus 60. Do we need a reason there? No, we don't need a reason. Because 115 is on the diagram. If you're one of those girls that really need to write a reason, you can write given. But as I said, it's on the diagram. Given that ACE is equal to 112. Okay, which makes that angle how much? 55 degrees. Now what? We go with the alternate angle. So angle 1 is equal to Fine. Alternate angles equal, and CD is parallel to E. Any confusion there, people? No? Next. Given the triangle HEF, with HE extended to A, means to say extended is that line is HF continues to point A, extended in this case. FD is drawn parallel, FD is drawn parallel to EH, and D and H are joined and extended to B. And D and H are extended. There we go. It's a little bit longer extended to B. It's also given that HF is the bisector. So we tell that HF is a bisector of EHD, which means to say that this angle here is equal to that angle. That's what bisector means, cutting off. Complete the following and supply reasons where required. Okay. So angle 2. What do we know about angle 2? Angle 2 is equal to? Remember these lines are parallel here. To angle 8. Why? It's corresponding. Corresponding angles with DF being parallel to HE. Alright? Yes? You said angle 9. So it's the same, right? So you're saying angle 2 is equal to angle 9. The only time that will be right if that line is extended, then but the opposite angles will be equal. So can it be equal to 9? No. Okay, somebody else said something else? You said angle 2 is equal to angle? Huh? Somebody else said angle 2 is equal to angle? Angle 5. Is that what you said? But it's fine. It's okay to make a mistake. I would like to know what angle did you say? 7. Angle 2 and angle 7. How did you get angle 7? Alternate. But what is angle 7 actually equal to? Understand, Michael? It's fine if you make a mistake. So we can highlight it and show the others not to make the same mistake. That's the idea. Okay. People, angle 4, 5 and 6 is equal to the sum thereof. 4, 5, 5 and 6. They add up to what? 180. Why? Exterior angle of triangle, you all agree with that? No. See here? If you're going with exterior angle, that line must be extended. That exterior angle is equal to those interior opposite angles. Nope, not that. Not exterior angle. Look at the question. It says angle 4 plus 5 plus 6. Angle 4, 5 and 6 equals to 180. But why? Huh? You also ask him why. Nice, nice. Criterion? No. Yes, 4 is outside. But it's 180. It is 180. You guys are missing a vital information that we read earlier. You're so confused. Look here. What did they say here? HF is the bisector. So angle 3 is equal to angle 4. You see here, these angles adds up to 180. Not so? But this angle and that angle is the same. And the reason they sum of triangles. But if you look at what is given here, it doesn't fit in here. Not so? So they got degrees in. Oh, it's 180 degrees. The reason? Sum of triangles. Okay, and this triangle. Put your triangle. H, E, F. That makes sense, people? See what they said. Yeah, same. That HF is your bisector. Not so? Nice, nice question. Nice exam question. Right. Yes. Yes. Right. Number 3. Angle 1, 2, 3, 4, and 9. 360 degrees. Why? Or revolution. They don't have it there, but we are nice people, so we write it. No? Not all of us, but some of us. Right. Take us away. Angle 1 and angle 2. Angle 1 and angle 2. That's the sum thereof. Is equal to angle 6 and 5. Why? Nice. Exterior angle of triangle. Not so? And which triangle is that? Triangle HEF. Do I have to say this here? No, you don't have to say. Okay. Right, last one. We'll go with the blue. Twice angle 3. But remember, 3 is the same as which angle? 4. That just don't forget. Twice angle 3 plus angle 8 is equal to what? 180. Twice angle 3, so it's angle 3 plus angle 4. Plus angle 8 adds up to 180. Why? Yes. With HE being parallel to DF. Okay. Do you guys understand? The sounds of it, some of you are ready for the exam. Right? Listen, you shouldn't be copying wholesale now. Okay, I'm waiting. Huh? You shouldn't be copying. Huh? But just correct your work. Otherwise, you must wait for your whole day. Right, you ready? Next. Sums is just getting sweeter and sweeter. Eh? Right. In the diagram, this is the drawing now. No? For those of you that know what diagram is, the drawing. AD is equal to DC. AD is equal to DC. People, that's already on the diagram. With that given, what can be concluded at this point already? AD is equal to DC. What can be concluded at this point? Angle A is equal to angle? Can I just say angle C? No. I must say DCA or ACD, the same thing. And what account and what theorem are we using there? Angles opposite equal side. Not so. Not O, it's not O, it's a D. Right? Then we are told that DE is parallel to BC. What can be concluded there now? Corresponding angles are equal. Co-interior angles are supplementary. There's no alternate angle. Corresponding angles that way as well. Not so? You all agree with that? Co-interior angles that way as well. So, by just saying that is parallel, all of those things should come to mind. Alright? You all okay with that? Alright, let's answer the questions. Calculate with the reason. BDC. BDC. You're too fast, Michael. But nice. BDC. So we will go sum of triangles. Okay? So it's going to go 62 plus BDC plus 28 equals 180. Why? Sum of triangles, and it's triangle DBC. So BDC is equal to 180 minus 62 minus 28, which gives us 90. Sorry? 90 correct? Okay, which confirms whoever wrote in the book is correct that time. Okay, you must write in the textbooks, no? Right? B. It asks you to calculate EDC. EDC. Are you going to calculate this angle here? Alternate angles. Can you all see that, people? Are you writing down? Don't tell me later. You am. You got it right. Nice. So that's 90. This is 28 degrees. Okay. So EDC. We said it's going alternate with DE being parallel to BC. You all agree with that? Alright. Let's look at C. ADE. ADE. ADC. This one here. It's actually this angle here. No? Am I right? AD. Yes, is that angle? Yes? Okay, just hang on, I can't hear. Yes?
So, for example, if it says ABC, you have to calculate inside ABC, not
ADC. They want this angle.
Inside, so like, can you also calculate outside?
Oh, you're talking about this angle here? Wait. Is that what you're asking? You're not sure what you're asking?
I'm not asking them. So, can you also calculate outside, for example, you can say corresponding.
Corresponding.
Can you also say that? Oh, yeah.
For this angle here?
So she's talking about
Wait, if you all talk at the same, I don't know what you say. Yes, you understand what she's asking. Yes, okay? Yes? With this one?
Yes.
Oh, so you're asking this angle here is corresponding to this angle.
Yeah.
But now you see, this line here is parallel to that line. Just highlight for you here quickly. Highlight that. This line is parallel there. So if you look at corresponding angles, it's that angle and that angle. So it's not the case. Okay. Although those angles are corresponding, but are they equal? No, because the lines are not parallel. The corresponding angles will only be equal if the lines are parallel. So if you look at this here, if you got that there, are those angles corresponding? Yes, the if can be formed. But are the angles equal? No. The only time the corresponding angles will be equal if the lines are parallel. Make sense? Yeah. So no, not in this case. Angles on the straight line, absolutely. So it's also going to be 90. So you're going to say that ADC is equal to 180 minus 90. Angles on the straight line, which gives us an angle of 90 degrees. Okay? Yes? 28? You see, if the question was to calculate ADE, then it would have been 90 minus 28. Or it would have been 90 plus 28 plus that angle would have been equal to 180. Angles on a straight line. You understand? But now, if we look at the question with the angle they want, the angle they want is ADC, which is this angle here is the angle they wanted. And not this angle here. You see the difference? You see the difference? Yes. Ask, don't be shy, ask.
Not making sense.
Not making sense, okay.
Because you skipped.
Did I skip?
Wait, no.
Hey, you see, yeah?
That angle that's equal to 90 degrees.
Yes. Okay, wait. Let's take a away. Let's take it away. We have that angle there. Not so. The angle, don't consider this 28 yet. The angle they
I'm
want.
not talking about that 28. I'm talking about the 28 that's there.
Yeah.
Yes.
But what I'm saying is don't consider 28 now. Just hang on. They want angle ADC. So that 28 is within the angle they want you to calculate. Can you see that? That 28 is within that angle. So how do we calculate angles on a straight line? They add up to 180. That is why I said 90 degrees plus ADC equals 180. Angles on a straight line. So ADC is equal to 180 minus 90, which is 90. Which confirms what happened. You must look past the 28 at this point. Because that 28 is part of this angle here. Initially, when I started off that question, I also thought I wanted this angle here. For angles on a straight line. Then I would have said 90 degrees plus 28 plus that unknown angle equals 180. Angles on a straight line. But they don't want that. You understand what they want now? Okay. So this is. So at this point we got 90, we got 28, and we got 90 degrees there. Right, next. D. DCA. Let's change the color. DCA. That angle there. What angle DCA? Sorry? DCA. DCA. How do you mean DBA? Oh, you looked at the wrong one. Okay. So I'm on the right track. So DCA. So you see, that's the angle they want here. Not so? But DCA is the same as angle A. How do I know that? Angles opposite equal sides. Not so? So we're going to say that DCA is equal to angle A. Why? Angles opposite equal sides. So we can say that DCA plus angle DCA plus angle A, which is also DCA. The reason why I make it the same, otherwise I'm going to have two unknowns in one line. So I keep it the same so I can have one unknown that I can solve. So that angle here plus angle A plus that 90 degrees adds up to what? 180. Okay, that adds up to 180. Sum of triangles. And this triangle, DAC. Again, you don't have to name the triangle. So I take 190 over the equal sign. Becomes 2DCA is equal to 90 degrees. Then what do? I divide by 2 both sides. So DCA is equal to 45 degrees. You guys understand? So what I do now is I put 45 degrees on the diagram here. And 45 degrees, because I now know that is the same. You will get an answer book in your final exam. An answer book. And you see what I'm doing to this diagram here? You do the same in your answer book. Don't do that on your question paper. So when we get your answer book at the end, after you've written, then we can see your logic or your process that you went through to get your answers. Okay, it makes it a bit easier for us to follow your argument. Okay, and also if you made a mistake, it's easier for us to follow through your mistake, to give you positive marks. Okay. Okay. So the next question says to calculate DEC. DEC. DEA, sorry. DEA. I'm going to calculate that angle. Sum of triangles, not so? But if you're looking at sum of triangles, we have two unknown angles here. We don't have this angle. We have this whole angle here. We don't have that one. Okay? Otherwise, we could have said 90 minus 28. And then I will have this angle. Then I can go sum of triangles. Not so? But it's another way I could have done this. Is this not the exterior angle of this triangle? That's so? So we say ED equals 45 degrees plus 28, which is 60, 73. Let's check if that's correct. And your reason there is exterior angle of triangle. Got. Which means to say exterior angle is equal to the sum of the two interior opposite angles. And this is the triangle ED. Okay, yes? Shh, you make a noise. Yes? Corresponding angles. Let's check. Absolutely. You see that angle is equal to that. So it will be 28 plus 45 is equal to that angle by corresponding angles, and you say which lines are parallel. Absolutely. Okay. So for the next question, question 4. Don't forget your 10 minutes for starts now. It says, prove the theorem. The exterior angle of a triangle is equal to the sum of the opposite interior angles. Okay. So what do we notice here? AB is parallel to C, not equal, parallel. For that being parallel, what do we know? Angle B is corresponding. Angle B is equal to angle ECD. Why? Corresponding angles with EC being parallel to BC. Not so? What else can be determined at this point? Alternate angles. Angle A is equal to angle C. So what do we notice now? Is this exterior angle not equal to the sum of the two interiors? They have proved the theorem. So let's write it out. So we started off here. We said angle B is equal to ECD. Why? Corresponding angles with EC being parallel to AB, or AB is parallel to CE. Then we said angle A is equal to ACE. Why? Alternate angles are equal. Not so? Then what is supposed to have written here? Lines that are parallel. I would have lost the mark. AB is parallel to EC. So we say since, we state the obvious. We say since angle A plus angle B is equal to C angle C, E CD plus ACE. You see that if I add those two, it has to be equal to that. If you say angle A plus angle B is equal to, it has to be equal to the C. Can you see that? Therefore, you can conclude that your exterior angle of triangle is equal to the sum of the two interior opposite angles. Right, you guys understand? Any confusion? Okay, let's carry on. What? You think I make a joke? Maybe I tell you and keep you in because I'm your root. Right, next, last question before we leave. Calculate with reason angle 1, 2 and 3 from the diagram. Angle 1, angle 2 and angle 3. How are you going to calculate angle 1? Look where angle 1 is. Sum of triangles. Not so? That's really simple. So let's say angle 1, or I could call this angle A1. This could have been E2. This could have been F3. You see that subscript there? That's how I name the angles, okay? With a copy on top. Is to refer to the angle. Otherwise, if you have A1 like that, it's also the angle. That angle could also be named as BAC, which is that angle. Okay, all that means the same thing. And you need to know it all because sometimes they give it in different formats. So I'm going to just go with the way they wanted you to represent it. So we said angle angle 1 plus angle 120 plus 30 degrees equals 180. Why? Sum of triangles. It is triangle ADC. So angle 1 is equal to 30 degrees. You all agree with that? Okay, this person who wrote in the book back then, he knew his maths a bit, no? But you guys know it more than you, isn't it? Why you look so surprised that I have so much faith in you? Let's look at number 2. I'm going to calculate number 2. You all agree exterior angle of triangle. That one was a bit hidden, huh? You see the exterior angle there? You all see it? Okay. So I'm going to say that angle 2 equals what? 30 degrees? $30 plus 40 degrees. Why? Exterior angle of triangle. The dot means exterior angle of triangle equals the sum of the two interior opposite angles. And it's the exterior angle of triangle A, E, B, which gives you an angle of 70. Okay, you guys understand? Yeah. And then for number 3, are you going to calculate angle 3? Sum of triangles, here again. You see that, people? So angle 3 plus 70 plus 30 is equal to 180. Why? Sum of triangle. And this triangle if EC. So angle 3 is equal to 180 minus 70 minus 30, which is 80 degrees. Right? So for homework, okay, so if we just check it, what we have left of this paper, we shall have C of question 4. And then question 5 we'll answer in tomorrow's lesson, inshallah. And then I want you guys to do for homework. You do for me the first paper of November, and that is on page 199. Okay? That paper is 150 marks. So that should have been 2.5 hours. Let me just check here how many hours did they stipulate initially. 2 hours. So I would give you up until question 3. Okay. And the first half of question 4. So you do up until 4.1. Okay. We'll answer that tomorrow as well. So you guys sorted. Is that enough homework or you need more? You more? Oh, enough. Okay. Enjoy the rest of your day. Good morning, class.